This is 7.4 reciprocal functions, day 1. In this one, we are going to focus on linear reciprocals. So a reciprocal is a number multiplied by its reciprocal. So if we remember that, if we had 2, its reciprocal was 1/2. So we are going to deal with that now in functions, as long as the function does not equal 0 in the denominator, because that would mean our function is undefined. So we're going to sketch the graphs of y is equal to x and y is equal to 1 over x, this being the reciprocal, on the same set of axes. I'm going to pause, fill in the 2 charts here, and you should do the same. Okay, as you can see that I have graphed the original function here. This is y is equal to x. Then I want you to fill out this chart here, and then we'll go through graphing it together. Okay, with this filled out, you can see that we have an unusual thing here. This is where the graph will be undefined. So that means we have this thing called an asymptote. So then that should look like this. A dashed line that is going to keep us from graphing on it. What we're going to do is we're going to graph kind of the easiest points, which we have at -1 and 1 and 1 and 1. Then we know that if we go from -1 at -2, we have a half. And then -5, so 3, 4, 5, we have a fifth. And then it just keeps getting smaller and smaller and smaller. And the same thing is going to happen over here. So what we are going to do is just kind of hook it like this. Now this is going to approach the asymptote, but never cross it and never touch it. It'll get really, 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 really close, but it won't. And the same thing's actually going to happen here. So you just draw your line, come down, and you hit the axes. And this is actually an interesting point to see that we're also never going to cross this horizontal asymptote either. So if we look here, we have at x is equal to 0, we have an asymptote. So in our function, we could never have that y is equal to 1 over 0. That's true, so that is undefined. And then if we have here that y is equal to 0, if we try to solve this, we have that 0 is equal to 1, which is not true. So we also have asymptotes in the horizontal axes. So if we go here and we examine it, our domain for y is equal to x, we know that is x, such that x is an element of the real numbers. Our range stays the same. Oh, that should be black, okay? So as x becomes a very large negative value, what happens to y here? Does it also stay the same? Does it also become a very negative value? So then y becomes very large. Y becomes close to, and then as x becomes a very large positive value, y becomes a very large positive value. So same thing. Behavior at x is equal to 0, y is equal to 0, and our invariant points, the ones that stayed the same, we know it is at -1, -1, and 1, 1. Now if we look here, let's compare this. Our domain for our function changes now. It is x such that x cannot equal 0, but x is still an element of the real numbers. And we know the same is true for y. Now as x becomes a very large value, then y should be what? So if we had, let's say this example, y is equal to 1 over -100. So as x gets bigger, y becomes smaller. As x becomes a very large positive value, same thing. The big thing here is that they get closer to 0. I don't like it when the board does that. Our behavior at x is equal to 0, we are undefined. Okay, so this is a handy chart to reference as we go through this, as you need help with refreshers. So it says here the function is a rational function that has two distinct branches located on either side of the vertical asymptote, which is the non-permissible values of x, which we talked about in last chapter. An asymptote is a line that a curve approaches. We have vertical ones and horizontal ones. And we kind of discussed that already. So these are our steps. You will always follow these steps. So I'm going to walk through a linear one with you. Write the reciprocal. So that is simply just 1 over the function. Determine the equation of the vertical asymptote. So we are only worrying about the denominator, so we will isolate the denominator, set it to 0. And x cannot, the equation of the vertical asymptote is x is equal to negative, that is 2.5, so 2.5. Determine the invariant points. So all we have to do is we sub in 1 for the equation. So 1 is equal to 1 over 2x plus 5. 2x plus 5 is equal to 1. Subtract 5 over. 2x is equal to negative 4. Divide by 2. And we get x is equal to negative 2. So that means we have a point at negative 2, comma 1. Next one, we set it to negative 1 now. So negative 1 is equal to 1 over 2x plus 5. Negative 2x minus 5 is equal to 1. Add 2x, subtract 1. So you get negative 6 is equal to 2x. And then we get negative 3 is equal to x. So then we have a point at negative 3, comma, negative 1. Those are your invariants. Find the x and y intercept. Well, let's try. So x-intercept. If I go that y needs to equal 0, well, we should see here that we get something that doesn't work. So that means we have a horizontal asymptote. At y is equal to 0. Our y-intercept. We should recognize this from quadratic functions, that it's just the constants within the function, but let's walk through it. So it'll be y is equal to 1 over 2 multiplied by 0 plus 5. So y is equal to 1/5. So let's graph this. Okay, you can see here that I have the major points plotted. Oh, I did forget one thing. I need my dashed line. So even though you can't really see it, I'm actually going to change the color on that. You still need to plot it. So that is y is equal to 0. So I have my major points plotted here. I have 1 point here on the right-hand side of the asymptote and 1 point here on the left-hand side. And I also have my y-intercept approximately because it's 1/5. That's a little hard to see. Now all you have to do is you have to connect those like that. And it doesn't need to be any more accurate than that. Just remember that you cannot cross your asymptotes. Then it also asks us to graph its original That should be more than fine for us to do, because if we look at this, in the original, let's do that in blue, right here is the x-intercept, and then the y-intercept should just be 5. So then 1, 2, 3, 4, 5. And then you would just connect those dots. So let's do that. So we can see here that we have these invariant points that we talked about before at those 1 spots. So we can see kind of how those all relate together. So you can head off and go practice graphing reciprocal linear functions.